This video is about mathematical model, setting of differential equation, and solving it. We have a problem where a man-made lake initially contains 200 gallons of water with 50 pounds of chemical dissolved in it. A solution containing 3 pounds per gallon of chemical runs into the lake and at the rate of 4 gallons per minute, and well-mixed solution runs out of lake at rate of 4 gallons per minute as well. So here is the man-made lake. Uh, and it's two initially it has 200 gallon of water plus 50 pound of chemical in it. A solution runs in a solution of 3 pound per gallon runs in at a rate of 4 gallon per minute, and a well-mixed solution runs out at 4 gallon per minute as well. So in order to solve this, let qt be the amount of chemicals at time t minutes. So initially the amount of chemical presence was q0 was 50 pound. The chemical flow in rate at the rate of 4 gallon per minute and flow out at the rate of 4 gallon per minute also. So the volume at any time t, Vt is going to be 200 gallons only. So we know rate of change, that is dq over dt, is rate in minus rate out. So in order to find rate in, we know the formula concentrations of solution times the flow in rate. Here the concentration is 3 and the flow in rate is 4. So when we multiply it, we get 12 pound per minute. And the formula for rate out is same as well. The concentration that times the flow out rate. We don't know the amount of concentration, but we know that the concentration is amount of chemicals over the volume. Here we already said the amount of chemicals be qt, and the volume is the volume of lake, that is 200 times the flow out rate, which is 4. So when we multiply it, we get qt over 50. Now we get after that we get the rate of change dq over dt is 12 minus qt over 50. This is the differential equation, study of differential equation, also known as initial value problem. Now in order to solve this initial value problems, we need to find the integrating factor. Beauty To find the integrating factor, we just get the exponential integration of the 1 over 50 from here, and after that we solve it and we get e to the power t over 50. We multiply this e to the power t over 50 in the equation 1, and we get this equation right here. And we can see that this equation is in the form of product rules of a derivative. So when we solve it, we get this simple equation, and after that we integrate both and we get this equation right here. So when after this integration and the derivatives get cancelled, and after integrating this we get this value right here and the constant c. So finally we are left with qt equals 600 plus c over e to the power t over 50. And let's consider as equation 2. After that, we solve the value of c. In order to get the value of c, uh, we put time t equals to 0, and we already know that at t equals to 0, the qt is 50 pounds. So we substitute that 50 on that equation 2, and we get 50 equals 600 plus c. We only get c because at t equals 0, this value becomes 0. So, and after that we get the value of c as negative 550. We plug that value in on that equation 2 in order to get this equation right here. That's equation 3. This is basically solving the differential equations. And after that, after solving the differential equation, we need to find the maximum uh, chemicals at a given time t. In order to do that, the amount of chemical is maximum when the rate of change is 0, that is max at the concentrations. So we made dq over dt as 0. From equation 3, we get this equation right here. And after solving the equation, we get 11 e to the power negative t over 50 equals 0. We know that 11 cannot be 0, so e to the power negative t over 50 has to be 0, and after solving it, uh, it can only be the value of this value can only be 0 when t is infinite. So the maximum of chemicals in the lake is 600 octane at t equals infinite.